Hi, I'm Dave Robinson, and welcome to another one of my screencasts where I'll be using R and RStudio to analyze data I've never seen before. As usual, the data comes from the amazing Tidy Tuesday project, a weekly data project in R from the R for Data Science online learning community. I'm really excited to get started up, and let's see what we have this week. Right, we have Australian pets. I saw Australian animal outcomes, but it looks like pets. Oh, is this like pets in veterinarians? I haven't looked at this data. It looked even less than I usually have. Was it animal complaints? Okay, so and it's in Australia. All right, animal outcomes, some cleaning scripts. Lots of details going on here. Data cleaning, data aggregation. All right, we have 3 different scripts: animal outcomes, animal complaints, Brisbane complaints. All right, let's get started. The Tidy Tuesday R package is a new package called use tidy, as a new function called use tidy template, which I thought would open something. Let me. Do we need to have something open? I'm not sure what. No, it's not. It's not doing the tidy templating that I would expect it to. That I've expected it to. Let's see. Maybe if someone's here, they know what's going wrong with it. Open equals true. No. I actually did test this out recently and it worked. So I'm going to try it one more time. And we're off to an amazing start. Tidy template. I'm not seeing any template. If I look at... Oh, I get it. The problem is I'd already created it as a test, and it created it, but it didn't open it. Okay, so that's something that we learned today, is that it created it, but it didn't open it. All right, so then let's go through, and we're going to, we get this whole template, and it says things like, load tidyverse, load tidy Tuesday R. It doesn't have my personal favorite, which is theme set, theme light. And then it has a step to load the data set. So Tidy Tuesday, and then now we can start by looking at the README. Animal outcomes, animal complaints, Brisbane complaints. All right, so this is kind of neat because it gives us like a template and a place to get started. And ooh, look, it even does show each of the tables. I kind of like this. That it can say Mac glimpse. I haven't done that step before. Yes, I can say, look, we have year, animal outcome, this whole thing. But what I like to do is I like to start just with TT animal outcome, Let's start with the animal outcomes. All right, and there's a sad data set. There's cats getting euthanized, reclaimed. Okay, this is cats that are being, this is animals that are being, presumably, like, where is it? Let's see. It's the RSPCA. Okay, it's like, I think in America we have the ASPCA. It sounds like that's similar. All right. And then we're in, yes, the country. Adoption and reclaiming rates have been increasing over time, and improvements in the outcomes for cats and dogs. All right, then yeah, I have a good feeling for how we're going to go about this one, which is, let's start with animal outcomes. And I'm going to rename total to be total, to be lowercase. I didn't do that to all the columns. I only did it to to this one. Why didn't I do it to all the columns? Because I probably want to reshape these. These are regions within Australia. What are they called? Provinces. Help me out. Australia. Any Australians in this group? What time is it in Australia? What is it? It's 16 hours later, something like that. Okay, so then it's middle of the night. I doubt there are any Australia. Yeah, no, wait, 8 hours earlier. Oh yeah, I bet there's Australians could totally join. I'm not great with time zones, I'm able to tell. But yeah, the story is we're going to be using these regions. I think this is New South Wales. I think, what is this, Victoria? I really don't know my way around Australia, though I did go to Australia 2.5 years ago. I had a wonderful time. So there's outcomes, euthanized, other transferred, but there's N. What we really care about is maybe weighted by the total. All right, so most animals were euthanized. Some were rehomed, reclaimed, transferred. I'm going to work around the total to start. So I'm going to actually say, here we go. I'm going to do it by, I'm going to do it by year. And then this we can plot as year N fill equals outcome stacked bar plot, since it's they're components of total. All right, so this is showing that the overall number of animals has been staying something like steady, and there are some animals currently in care since in the last 10 years or so. Animals really being watched over them by something like a decade. All right, yeah, and then we have data we have data on ones that are released or transferred. I may want to reorder this. I may want to say outcome equals FCT reorder outcome by N, the based on the total, the sum. So then I can say, check this out. That lets me put the largest ones here in the bottom. So I can say the most common is euthanized, rehomed, reclaimed, transferred, so on. I might also want, before that, I might do an outcome equals FCT lump, outcome for 5. Oh, I needed to do weight. Outcome for weighted by total. Otherwise, it's going to be, is it weighted by N? It's going to be called N in this case. Yeah, I needed to show the most common ones. Yeah, so we lumped these. What would it look like with 6? Yeah, maybe we stay with that. I don't know, how many were there total? Not that many more, there are about 7. All right, I'm just going to keep it as it is. All right, so then we can say number of animals. Number of animals. And X is year. What is that? The year that, let's check the help. Nope, not the help, the viewer. And we'll check the full year. Full year. Year, I think it's the year they were like brought in, because they're still currently in care. I'll just put year because I'm not 100% sure what it means. But yeah, this is showing the outcomes of animals that were taken to the RSPCA's care. All right, so now we have a, let's see, yes, now we have stack data set. There's, I don't know what in stock means. I wonder if in stock and currently in care mean the same thing, and that's why in stock stops and currently in care starts. Here's a way that I can get a little bit more of a feel for that, because I can say this is not going to be a great graph, but it is going to dodge. This is not a good graph, but it is going to like tell me this is an even worse graph than I thought it would be. Instead, what I'm going to do is do a here we go, Geom line. Change this to color. Could have been faster too. Yes, I have a suspicion. There it is. In stock and currently in care look like synonyms. Why? Because they're kind of continuous. This is one year, this is the next. I think they changed the definitions. There's a function we can use for that, and I'm going to use it up here in the cleaning. I'm going to say outcome equals FCT recode. Recode the outcome. Let's make in stock become, look other way around. Let's make in stock become currently in care. So it's a data cleaning there. And check that out. Now we can kind of see like more of a steady green line across this. Anything else that gets combined? I didn't do an FCT lump in this case. So the other is actually was other in the original data weight equals total. Weight is, oh, it was capital T in the original. Yeah, so other is just like other in the original data. All right, and then very few released, and that might depend on the kind of animal. All right, so this was us looking at some things based on looking at some visualizations. You know, is this a better plot? This might be a better plot. We can choose between the stacked bar chart and the line graph. I kind of like this one. It doesn't show as much about the total, but the total isn't that interesting here. So yeah, I'm actually going to keep this as it is. Number of animals with this outcome. That's pretty solid. Here's what I'm going to do. I'm going to also do this as another one. I'm going to do this faceted by the animal type. So what I'm going to say is here we go, animal type, outcome, animal type. But before I do that, I should really count the animal type. Weight equals total. Dogs, cats, wildlife, other livestock, very few horses. I could lump horses. No, horses are not livestock, I suppose. They're just going to be so much smaller. Well, let's take a look at what it looks like. What I'm doing is, here we go. And scales equals free y. And let's do a few other things. Let's say animal type is FCT reorder. I want these sorted to go like the biggest ones, whether dogs or cats, first, but then end with the smallest, like end with horses. Animal type by negative and sum. Why negative? Because I want in descending order, and that's the dogs, cats, wildlife, other animals, livestock, horses. Let's look at this one. And let's do a few other things. Say color outcome. You know, do I want to lump the rare ones together? I think I kind of want to lump the rare ones together just because it's so rare. And like, what am I going to do with all these lines? I don't know. Maybe it's not terrible. Okay, so yeah, this is kind of informative. I'm going to do a little more to clean up this graph. I kind of like this graph. Scale y continuous labels equals comma. I neglected to do library scales. I bet I can customize my template and work with that. Yes, I think I probably will do so. It'd be nice to start every week with a template that I want. Labels is comma. And yeah, let's talk about our conclusions from this for a second. The big thing we see here, and it's mentioned in the README, is somewhere around 2010 to 2013, there's a major decrease in the number of animals, the number of dogs and cats that are euthanized. In turn, there's a sharp increase in the number of wildlife that are euthanized. That's interesting. Now, on the other hand, we can also say that the hits me. I'm going to need. Notice that you don't have zeros in this graph, and that actually gets a little bit confusing because, for example, like there could be some values that stay close to 0. So what I'm actually going to do is complete the graph. So complete the table. So notice there's count like this. What I do is I say complete every combination of animal type, outcome, year, fill, n equals 0. This is from tidyr package, and now I say, oh, there was 0 in these 3. And I have every combination of these now filled in with 0. And we can see that, okay, that released is like stays flat at red. Red at release stays flat. It's very rare for animals to be released. Maybe some wildlife are. Can't really see here. It's so rare. All right, so yeah, I like the graph a little bit more. I think it's clear when things go down to 0. There's other things we see here. A lot of livestock got transferred in the year 2012. Could be real. There's a spike in horses in recent history. Horses, just any data on horses, but a lot of horses that are currently in care. And they started dealing with horses more. Other animals increase. Who knows what kind those are? But yeah, mostly the most important thing, overwhelmingly the most data comes in dogs and cats, and we see there's a decrease in euthanasia. Did I mix something up? No. Here we go. Lots of dogs are reclaimed. Very few cats are reclaimed. Does that sound right to you? What's purple? Reclaimed, rehomed. Huh. Look at this. Very few cats are reclaimed. All right, so actually I'm going to dig into that a little bit more, but to dig into that, I want to look just at 1 year. So I'm going to look at, so I want to actually dig into the difference between animals, and looking at that over time is not a perfect way to examine it. So I'm going to filter only for people wondering what I'm going to do with these. I've got plans, I just haven't gotten to them yet. Year is max year. What is that, 2018? Great. And let's do animal. What did I do a count here? Did I do a count here? For no reason. There's no data there's no extra data that adds. What was I doing? That count was on single rows. Look at me go. All right. Well, the thing that I do here was, sometimes I notice that when I'm making the next graph. All right. So the thing that I'm going to do is say animal total, geom call, animal type total. Nope, I'm going to actually do outcome total, geom call, stacked bar plot. I'm going to say mutate outcome is FCT reorder outcome by total. I'm going to flip the axes of these. I'm going to put total first. Long-time viewers recognize this as my favorite graph. Is this still grouped? Is this still grouped? Oh, by sum. Here we go. And now what I do is I say facet wrap by animal type. And here we go. All right, so what we see here then is that many cats are rehomed, fewer dogs. Not a lot of cats reclaimed, many dogs are. So this is one way, yes, we can say like, what is the distribution of outcomes for each animal? Noticing this, I'm going to want scales equals free x, not free y. The y-axis I'm going to keep the same so that we can more directly compare between these. It shows that wildlife are never rehomed or reclaimed, which makes sense. They're typically either euthanized, transferred, or released. We also see that nothing gets released besides wildlife. That makes sense. Nothing else you would want to release. Yeah. All right, and let's see. Just catching up on what everyone's chatting about. All right, so this is a I like this graph too. So I'm going to say x is total number of animals in 2018. I don't need a y outcome. What are the outcomes for different animal types? Subtitle in Australia in 2018. All right, so this lets us just divide up that data into facets, learn a couple things from it. Most other animals are rehomed. That might indicate that other animals, I guess, I don't know, mice, rabbits, ones that can be pets. All right, so I haven't even looked at the provinces yet, and we're going to start right now. So we've learned already some things about changing over time and difference between animal types. I'm going to look now at the provinces, and to do that, we're going to be looking at this in a slightly different way. We'll say provinces. This is not the right structure of the data if we want to look at it by province. We're going to want to pivot it to be longer. We'll say that the names to are the province code, and the columns we're pivoting longer are ACT to WA. I'm still practicing using pivot longer, so I'm learning my way. Here it is. Okay, yes. There it is. And the values to total. No, it's not a total, it's a number. Call it N. Failed to create output due to bad names, doesn't like. Oh, because total was is a duplicate field. That makes sense. So I'm going to just call it N. So we have in the province ACT, 610 dogs were released. I want to get more information on provinces. Let's take a quick look at this for general regions of the states, regions. I've been saying provinces, but it sounds like they're called states. Do we have any Australians here? It is the morning in Australia. We decided, so maybe we do have an Australian in the who's watching. You don't have to volunteer if you do. If you are. There are, I see 6 states, and then let's actually quickly ask by, why do I like this pivoted longer? Because it's very easy for me to say filter year is 2018, count province code, weight is N. Nope, province, not provenance. And see here are the number of animals by province. I'm going to do a little bit more with that, but I just want to check. We have, so far I have 6. What do we got? There's Tasmania, there's Queensland, there's NT. What's NT? Northern Territory. Victoria, South Australia, ACT is Australian Capital Territory, and so on, then New South Wales. All right. I could get a total population of each of these. How would I get things, or a total area for that matter? How would I get things like that? Well, I can use Selector Gadget to do a little bit of web scraping on this. Can I? I thought I could. Let's see. I can't get this table selected. What I'm trying to do is find a, there it is. This table and not this table. I actually do want this table. Because I want both of them. How do I get this table back? This table and this table not, undo. And what I'm doing is I'm doing a bit of web scraping where I'm going to say I want these 2 tables. I'm selecting what things I want to match. There's only 2 things that match. This gives me a selector. All right, we're going to do a little bit of web scraping to pull in some data from Australia. I've done this in a few other screencasts. I'm going to do library rvest. I'm going to do read HTML from, one moment, HTML nodes from this page. Read the nodes, oops. Hmm. 23rd child, that didn't seem to work. I wonder, if I just did HTML nodes table, what happens? All right, there's a whole bunch of tables. If I did table, what if I said it looks like this? The problem, something's up with our ability to read these. It looks like this is not quite working. Nope. Nope, doesn't like that. I'm just trying to hack this together. Basically, I want to say what tables do we want. There we go. Class equals sortable. Okay, what I'm doing is web scraping is not always an exact science, and table class equals. Oh, it's no dot sortable. We thought it was dot sortable. Well, and then I say, okay, here's my sortable tables, and yeah, this, and then I can say map HTML table. So how does this look? Fill equals true, and turn each of these into a table. Map as tibble. Map janitor clean names. Map as tibble. What I'm doing is trying to, here we go, there we go. And I'm trying to grab all the tables out from Wikipedia. And it looks like it's the top 2 that we care about. If I do head 2, do I even need the, yeah, I always want the janitor clean names. Here we go. And now we have our states and our territories. So in a couple lines, we were able to get, yes, oh, thanks, Matt. We would have needed table dot sort table is one thing. That was the one. All right, not table space dot sort table. It doesn't matter because we have a sortable. Sortable gets us the same place. Thomas has suggested that we use map DFR. One thing I think is going to be an issue with that is that map DFR is that these are not the same shape. So I'm going to keep them as separate tables for right now. So if I do states territories 1, here we go. Now I have my state. Population. All right, and I'm going to do state, select, state, shorthand. I'm actually going to transmute rather than selecting. No, I'm going to select, and I'll show you why. Is that I'm going to say, yep, province code equals, can you believe that I went through all this work to scrape when I could have just probably done this, written this out by hand? Whatever. We're learning. String to upper, shorthand. I want to uppercase the code. Transmute. There you are. And what's the name of the, and then population equals, here's where I'm going to select it. I'm going to drop this because I actually want to say population equals, can I do this? I actually haven't tried this. Cool. I wanted to grab the one that contains the word population and the one that contains the word area without having to spell the whole thing out. So I could actually say, here we go, area equals contains area. I don't need other things like the governor. I don't even need the capital. These are the only things I might need. Now I do a little bit of cleaning. I say province code with string to upper of province code. I say population is read number, parse number of population. And area is read parse number of area. That'll get rid of those, commas. Cool. What about the second one? Similar. Drop this one, Jure display. That's like got so few people or so few anything in it that I don't even want to keep it. I'm just going to go ahead and say. And are both these the same? I'm just deciding how I'm going to. They're very close to each other. States, territories. Here I'm doing just a little bit of combining states, territories to combine them. Here we go. It's called postal here. Filter territory is not equal to Jervis. What is that? Jervis Bay territory. It's just not worth including in this case because it's got the same postal code and it's just a small population. And then I say name equals territory. Population. Here we go. And now I do bind rows of states and territories. Probably could have found this data somewhere online, but we had a Wikipedia. We had a Wikipedia link to use it. All right, state, province. I keep calling it province data. It's not a province at all. What I'll say is code. I'll call it code. State territory data. Why have I been doing all this? Because now I can take this, I can interjoin it with my state territory data by code. And now I have population area information. So I can say per capita. Let's say I'm still in 2019, so let's say per capita is total divided by, oh, I didn't do it in total, it should be n divided by population per million, per capita million. So the story is basically, you usually want something like, it's a little more interpretable if you say, here's how many there are per, here's how many dogs were reclaimed per million people, rather than work with these very small fractions. All right, so what do we see from this? We see as well that that ACT, Australian Capital Territory, is 13,000 dogs reclaimed out of 230,000 people, while New South Wales has only 24. Wales has only 24 dogs reclaimed per 8 million people. So one thing we can really sense from this is, okay, well, the it's not proportional to population. So what does that mean? It's actually I think it's actually interesting that we could have seen this data and said, oh, well, it's just going to be, if we do anything by territory, it's just going to be based on the population. The biggest territories have the biggest, have the most animals and reclaim. And that's not true. Northern Territory has the lowest population of really any of these that we're looking at right here, but the largest number of dogs reclaimed. So that's just like actually something to say, like, okay, we're not normalizing by population might be a little bit odd. It looks like it's really about the RSPCA, like what their activities are. But yeah, okay, I'm still going to keep that information. All right, so let's see, but that is only applicable in 2018 in our latest data because the population is going to change over time. The area is unlikely to change over time, but I'm going to divide this way. I'm going to say territory by state. No, I'm going to call it. I'm actually going to call it animal outcomes tidy. Is this? This is one thing we're trying. And this is in 2018 by territory. Let's think for a moment. And what am I going to do? I'm going to look only at dogs. I'm going to say, here we go, animal type is dogs. And we say outcome, think about this. No, it's going to be n outcome geom call facet wrap by territory. Scales is free x, I think. Should be by name. Name is a crummy. Name is a terrible thing to call this. I'm going to call this region. It's either a state or a territory. I'm also going to do a few other tricks that we saw earlier. I'm going to say region is FCT reorder region by n, the total, to put it in descending order. And I'm going to do something similar. I'm going to say outcome is FCT reorder outcome by n, also sum. Okay, and then how does the distribution differ? How are dogs? Oh, and I'm going to do dogs and cats. How am I going to do that? With another aesthetic. I'll say fill animal type and position equals dodge to put them next to each other. You really can't do that with more than, say, 2 types of animals, but if we're interested in cats and dogs, is that by far the most common ones? No, then this is a good start. Okay, so one thing we can see is that, like, something's up. Oh, yes. Yeah. Cats are very often rehomed. Dogs are often reclaimed. We already saw that on the overall data. Anything we see by province? Let's see. Let's see that. One is that some areas have less data in some than others, and again, that's not about population, because we saw that it wasn't correlated with population really at all. This is where the SPCA has their activity. Are there any where the ratios are different? Let's glance through. Okay, New South Wales, maybe as many dogs rehomed as cats, but that's one of the smallest points of data. Yeah, one thing is it does look like there are some regions that cats are more euthanized than others. For example, look at this ratio between these two, rehomed and euthanized. Notice that Northern Territory, nearly as many cats are euthanized, rehomed. This is all in 2018, which I actually should note. Let's say comparing cat and dog outcomes by region. In 2018, and I don't need a fill label. Yeah, if I were looking for a conclusion here, I'd look at something to do with percent of animals euthanized, and I would see that it's low in South Australia, Australian Capital Territory, relatively low there, relatively high in Northern Territory, very low percentage euthanized in New South Wales or in Western Australia. And noticing that uh, like trend gives me an idea for a new visualization, which is we're probably most interested in percentage of outcomes that are euthanization. There's probably others that we can get with some understanding of data, like some animals transferred are probably euthanized. Currently in care is kind of throwing something else in here, but yeah, we might be interested in percentage of animals euthanized, of cats and dogs euthanized by region. Over time. So let's look at that. Let's look at animal outcomes tidy. I'm going to inner join, but I'm not going to, let's see, I'm actually going to, here we go, I'm going to inner join up here. So we always have the region with us. We're not going to use the population over time because the population is going to be changing and we don't have that data currently. We're not going to be focused on per capita. All right, what kind of graph do I want to build? I know that I want to put a year on the x-axis. I know that I want to filter only for animal type, dogs, cats. I think I'm going to want color equals animal type, and I think I'm going to want y to be percentage euthanized. So here's what I'm going to do. I'm going to group by year, animal type, and region. And I'm going to summarize percentage euthanized as as n, where outcome is euthanized. I'm actually going to sum that. Why am I summing it? In case 0 animals were euthanized, this would be an empty vector, but the sum of an empty vector is 0. So by summing this, I ensure that sum of that over sum of n is going to be percentage of animals of this type that are euthanized. Does this look? Oh, so yes. Oh, well, we'll have to see once we have it on a graph, and that's 1. But I also want n is sum of n. No, that's not going to work. Total is sum of n. That wasn't going to work because it was replacing the n variable. And total percentage euthanized and facet wrap. I'm going to call this n animals to be a little clearer because we've used total in other places. Why do I need that at all? Because I'm going to be doing PCT euthanized geome point AES size equals n animals. It's really useful to have a denominator whenever we have a geome point, and then we have a geome line under that. Year percent euthanized, animal type, and facet wrap by region. Why am I facet wrapping by region? Because there's too many. 8 regions is really too many. Otherwise, to compare it using something like color. So then I'm gonna clean this up a little bit. Year, y equals percentage euthanized. Scale y continuous labels equals percent. And size is. I really like to have the points because it gets a sense of what are just noisier and what are less noisy. And one moment before I do this, I'm also going to say region. Mutate region is this. And I just caught a bug that was about to bite us, which is that after the group by and summarize, it's still going to be grouped by some things, which means we need to say, here we go, Region is FCT order region. Not minus n animals. Yeah. Show the ones with the most animals first. Okay. And most dogs and cats in particular first. All right. So what percentage of dogs and cats are euthanized? Historically, more cats than dogs. We have bits of missing data here. All right, spotting bits of missing data in certain regions. Yeah, overall, so we actually see, why is this important? Because we looked earlier and we saw a big dip in euthanization of animals around, that was in one of the first graphs we made, a little after 2010. This shows that a lot of that change was concentrated in Queensland, Victoria, and South Australia. But this being a smaller one, it probably had less of an impact. So it's probably a lot of the change was driven in Queensland. We can also see that in some, like Victoria, just been getting dogs been getting increasingly less likely to be euthanized. This could also, like currently in care, is sort of a confounding factor here, as we don't know if the dogs are going to be euthanized in the future. I could throw that result in. That's going to be hard to do. All right, so then, but yeah, this is showing like euthanization over time by region. Why is this broken? Oh, it's broken because of NAs. It's broken because of NAs. Okay, so I do not actually want, I want that to skip that year. Not is NA. In fact, yeah, I don't like, I think there just was some NA data in there. Yep. Oh, so it wasn't even that it was missing data, just like there was one NA somewhere. Why would there be an NA in N? Let's see if we can work that out. Animal outcomes tidy. Oh, for a particular read, yeah, filter not is NA. Oh, sorry, is dot NA N. And all right, it's very few, and it's usually, it's all in 2005. One of the, and for a few for dogs and cats currently in care, transferred, etc. All right, I'm going to leave it because the data looks continuous over 2005. I suspect it's still good data. See any jumps in 2005? I do not. Okay, so I suspect it's still good. That is that the data can be inferred to be 0, but it's worth checking. All right, here, there you go, euthanization over time. All right, that was a bunch of things I can think of to do on animal outcomes. Who wants to make a map and maybe an animated map? People feel like making a map? I have not made a map of Australia before, so I think I'm going to make a map. All right, the Shapefile Australia. Australian shapes shapefile. Do I need to create an account? That. All right. Australian states shapefile. Let's read this in. And I've done this as recently as maybe about a month ago, but that doesn't mean I'm going to remember how to do it. Read SF, downloads Australia states shapefile. Oh, look at that. Australia states. That took a while, I think. No, it might not have taken a while. It might have just been. All right, and then I can do. I think I've done this before. Do I do Geom SF? Is that going to work? Looks like this is a very, very detailed geometry, possibly. I really wonder, do I really need something this detailed? I wonder if there's ones out there that are less detailed. So I have a feeling that's why it's taking so long to plot. Though I could be wrong, and maybe someone could help me. All right. Nope, this is just Australia. I need the states as we have here. All right. Taking a long time. Does anyone know of a way we can downsample this geometry? Know of a way we can visualize it like more easily? Because yeah, this is, I think, yep, I feel like I'm crashing R right now. Australia states. How big are these geometries? Is that a thing I can like find out? Well, that's a geometry. Object.size, half a megabyte, and it feels kind of big. I don't know. It's a multi-polygon, and RSF downsample. RSF decrease resolution. G simplify? Alright. Maybe worth a try. Let's find out how this goes. Install packages. You can see me try something new. Because I feel like the plot's just not been working. And anyone else can try this. These are the only couple of lines I did. I just searched for Australian state shapefile, downloaded the first thing. Library RGOs. Alright, and RGOs. And RGOs has a function gsimplify. Let's try this. Numerical tolerance, okay. So Australia states geometry 1 has not an end row. There's only 161 points. Okay, then what's the one that is causing a problem? These do not feel big. Is length the right thing? Is length... What would happen if I unclass this? What is it actually? Oh, I see. Every one of those has like a whole bunch of shapes in it. Okay. Well, I'm going to look for, here we go. What's the biggest one of these? This is pretty big. And now I'll try RGO's gsimplify. Tol equals, I do not know whatever tolerance is, 10. Oh, it expects an SP object. What kind of object is this? Multipolygon. Not looking good. Not looking good. All right. Well, I don't know what we're gonna be doing here. Looking at this, getting a bad idea. Should I follow my bad idea? I have an idea. This looks like it's a list of matrices. That is, so let me try plotting it one more time. What if maybe I just got unlucky that one time. But if not, I don't think I did. I wonder if I can download sample this. Ooh, simplify. Is there an SF simplify one? All right, I'm out of luck. I'm out of luck on plotting it. SF simplify. ST simplify. Ooh, ho. Oh, ho, ho. ST simplify. That's in the SF package. Okay, that's good. Look at me crashing R again. I saw it happen once and I still let it happen again. Oops. It'll stop sometime. If not, I'll just crash it down. There it goes. Here we go. All right, ST simplify. Reserve topology, detolerance is, all right, so let's see how this does. If I say Australia states, I'm going to do it on a smaller one. All right, so this is the smaller one, and I say ST simplify. Detolerance is 0.1. Nope, it is 1. ST simplified is not correctly, oh, it needs to be in decimal degrees. Oh, I see. Longitude, latitude data, detolerance needs to be in decimal degrees. So there's a warning here. All right, decimal degrees. Well, I don't know. Wonder if it still works. I wonder if it's simplifying it well. I don't know what tolerance, numeric tolerance parameter. Oh, I really are freezing up, aren't I? Who wants to start over? I want to start over. Party time. All right, and I do start with the tolerance is 1. Let's rerun this step and this step and this chunk. Oh, I didn't load tidyverse. So this step and this step and this and this. All right. I'll just ignore the warning and we'll see. Pull geometry. Geometry set. No, I don't want to pull the geometry. I'm going to say simplified. What I'm doing is testing it. Geometry 1, object.size. Oh wow, that was smaller than it used to be. Okay, that might be too simple, and that is too complicated. Oh no, wait, simplified. Yeah, look at that. It's way smaller. Huh. I think this might work. Now the total size of the object is this, and whereas Australia states was far larger. I'm going to set a higher tolerance, shrink it by even more, and plot simplified. So that works. Hey! Hey, look at that! Ooh, thanks Thomas for bringing up the. So the advice of the day goes to Leo Kiernan, who asked about ST simplify. So that's actually, look at that. That's really cool, and it just plotted really fast, and it looks amazing. All right, so then let's finish out this step. What I'll need to do is take these states and notice that you've got a. Oh, actually, I should have taken the simplified one. Prints faster. I've got these simplified states, and I've got to interjoin it with the animal outcomes tidy by. I'm gonna make this as simple as I can. By what? Code is no ISO sub equals code, I think. But I'm going to do it only on animal outcomes tidy for one animal. I'm going to say, here we go. What I'm going to do is take this graph that I did earlier, this by year region, this and call it by year region. And the here we go, by year region. And I'll need to throw in code there too, otherwise I won't be able to join it. Here's my code. By ISO sub equals code by year region. Okay, now we have a much bigger version. And here, now I could say something like this. Filter, I could start by saying filter animal type equals dogs, year equals max year, 2018 I could say. And now I have only the 9 data points, 2018. Now I have the 9 data points, and I could pipe that into ggplot. Oops, let me forget that I want to say fill equals PCT euthanized. We're doing a time, all right. And scale fill gradient to low equals blue, high equals red, midpoint equals 0.5. Just trying to make it look a little better. Usually polygon edge, usually, they're not always, polygon edge not found. Just as a thing about this, if I resize the plot, we'll fix it. All right, percent euthanized is low for dogs. That's right, it's cats that were in the bad shape. All right, in 2018, this is like the ratios of cats. And can I do GG themes, theme map? Yeah, I like that. And I'll do a quick thing. I'll say labs percentage euthanized cats euthanized in 2018. I started 2 minutes late, so I have 4 minutes, and that is that we're going to find out if that 4 minutes is enough time for me to make an animation. What I'm going to say is I'll filter just for cats, but I won't filter on year. And instead, I'll say all these are the same, and I'll load in library ggAnimate to create an animated choropleth. I'll say transition manual, and every single time I forget this, percentage cats euthanized, and every time I forget this, title, year, I think this is something like it, and to be sure, I'm going to say time is less than 2002. I want the data to be a little smaller before I graph this. Year is less than 2002. Transition manual is by year. Oops, it's not time, it's transition time by year. Here we go, let's try this. That I usually get when the title doesn't work. Does somebody remember how to do this? I always forget how to do this. Frame, ggAnimate, title. Frame time. Frame time. I think that's right. Time, year. It's going to show partial years, isn't it? It is. It is. Integer. Yeah, I'm probably going to want to make this an integer. And I should have really just done transition time manual, transition manual. Then this is time. Wow, that got really, it's taken a lot of time just for our example to run. I always need a little bit of practice when showing my animations. Ooh boy, that's not, it does make it continuous, which is neat, but I am going to make it an integer, and I'm going to drop this, but I'm going to try transition time, year. I'm going to see how this looks. So this is actually now repeating the animated choropleth just for a couple of years. And we're actually going to see, like, we're going to try looking at changes over time. And look, while I'm at it, I really should have done labels are percent for the fill. Oh, wow. That's taking its time. I'm going to try transition manual. It doesn't like the title. I think it might be okay with this, though. Year frame. Oh, year frame, transition manual, and title. Let me see if I can get this right. Oh, here's the Stack Overflow, and I've totally looked at this recently. A lot of debugging today. I don't always debug, but when I do visit Stack Overflow. And here it is. It uses glue syntax, but it's not showing. I don't want frame, I want closest state. state. Does anyone know this one? I don't know this one. I feel like I just did this the other day. Really wanted to show the title. Oh, current frame. Oh. Almost done. And all right, it's looking pretty good. Yeah, because look at this. Its labs is percent euthanized, percent of cats. Oh, it's not X. It's gonna be. I meant to do a few things. Yes. Okay. I got rushed at the end, and cats euthanized in each province. Here we go. And here, yes, nailed just in time. What we have now is percentage of cats euthanized in each province, and let's watch it one more time. What we notice is it was like it's always been blue, and I don't know what this big left area is, but it goes up a little bit, maybe even there. But yeah, mostly there's a lot of places improve in the year around the year 2010. Watch that red turned blue. To dark blue even, yeah, to go to drop a lot lower. Yeah, so this is our animated choropleth. All right. So what did we learn today? We did a little bit of data cleaning with the FCT recode. We looked a little bit at overall outcomes over time, as well as breaking it down into particular animals over time. We also looked by animal and outcome and saw a couple of things that made a lot of sense to us, like that wildlife is released, other animals aren't. We also learned that dogs are more rarely euthanized, often reclaimed. Cats a bit more relatively often euthanized. We did a little bit of web scraping, pulling some data in from Wikipedia on the population area. Mostly we needed to get the names, and then we did yes, I need to drop this line. Yeah. Then we did we looked at by cat and dog regions, and that gave me the idea of looking at by over region and time. Once we started looking at by region over time with this graph, we realized that this being in region was a natural fit for geography. We brought in space shapefiles and created a visualization, an animated choropleth of Australia. All right, so that's a lot. We actually looked only at one of the tables. We only looked at one of the tables here, animal outcomes, but we saw there's a lot that can be gotten from that to explore these couple of dimensions and draw conclusions. Well, I really hope that that the work of the RSPCA continues and that a lot of more cats and dogs are rehomed or reclaimed instead of being euthanized. And yeah, I hope hope you had a lot of fun, learned something. I certainly did. I'll see you next week.